Well, good day to you, my dear friends. It's time to solve some LeetCode problems. Yay! First of all, I want to quickly solve a simple problem. Hey. From earlier days, from the first page, and it's gonna be what is gonna be this one, I think, number of unique subjects taught by each teacher. Ta-da-da, let's remove everything. So we have teachers, and they teach subjects in different departments, but they can teach similar subjects in different departments. Like here, this teacher teaches subject number 2 in different departments, but we do not care about departments at all. We just want to know how many unique subjects each teacher teaches. For example, this teacher 1, he has subjects 2 and 3, so all in all he has 2 subjects, and that's what we want to get. And this one has 4 unique subjects. So let's select the hell out of it. We want to get teacher ID, and we want to get count, I don't remember, distinct, of course. Distinct subject ID. Can't type it. Subject ID from teacher, and we're gonna group by, of course, group by teacher ID. Maybe not. Let's check this out. Oh, and also we want to call it CNT, count, I guess. What? Maybe we want to select distinct here. I don't remember the syntaxes. And count subject ID. Maybe like this. Maybe we need to put distinct here. Yeah, not like this. Well. Let's find a place for distinct. Much better. So this is problem 2356, and it's done. It's, I think, the best approach to this problem. I keep forgetting where we need to put distinct, but it'll come. And now for something a lot more interesting, because believe it or not, I was able to solve a rectangular problem. Whoa, where I am. Minimum area rectangle. On day number 5 I was able to finally solve this without looking at any solutions. I just found an error in my ways, a bug. So the logic was sound, but I needed to fix something. But let's go back to my previous solution. This one, I guess. And they told me, you should look into solutions from other people, or you should think of a different approach. Nah. Let's run it. Let's submit it. And we're gonna hit this test 108. So what's the story here? Let me first of all explain my logic to you, and then it's gonna be obvious what mistake did I make. So first of all, what do we do here? Now imagine that we have all these dots, and some of these dots, they have the same y coordinate. Like these dots have the same y. So let's say it's 5, and this one, let's say 4, and this one maybe 2, this one is 0, this one is -2. Right? So I go through my array of points and I create a hash, and as a key I use the y coordinate, and as a value I store an array of x coordinates. So it's gonna be a hash like it's 5, and it's gonna have, let's say this is 1, 2 and 3, something like this. It's gonna have an array 1, 2, 3, and this is 4, and it's gonna have an array like maybe it's 1 to 1, just 1 point we have on this line, and for 2 it's gonna be maybe again 1 to 3, I don't know. Oh, it's not, let me get back, it's just number 1, so let's have 2 and 3 for example. This is array of 2 and 3 and so on. Well, you understand how it's done. And see, I have a sort by here. I don't remember if I had it originally. Let's go back. Of course I hadn't. So they weren't sorted. And no quantum Chris, hello. I managed to solve this problem. The red? What? Everything is red? Where? Whoa. Oh, I managed to solve this motherfucker. Can you believe that? So my hash is sorted, but it doesn't really matter. Oh, I see what you mean. Yeah. So we have a hash and it's sorted, believe it or not. This is our hash. As a key we use y coordinate, and as a value we use x coordinates of all these dots. Oh yes, oh yes. Now what do we do next? Next we take our keys like 5, 4, 2, 0, and we iterate through them, and even -2 in the end. But in my example they're actually sorted because we do sort by. but it doesn't really matter. Maybe it does. It does. Let's sort. So it's sorted. Alright. Now what we want to do is add a new variable that I called offset. And by default it is equal to 1. And we create pairs using offset. We take the first element and we take the next element using offset. Offset is equal to 1, so we take the next element and we have a pair 2 and 0. Then we go to 0 and take again the next one, and we're gonna have a pair 0 and 2 and 2 and 4. Here we have minus, of course, 2 and 4. Four and 5. Maybe I forgot something. So we have this array of pairs, right? Now what do we do now? And remember that here we have keys for this hash, and we have -2 and 0, so we take this arrays. What is -2 for us here? It's 1. Probably we do not have a solution. Oh, we have a solution here. So instead of -2 we're gonna have 1, and instead of 0 we're gonna have 2. These are x coordinates of points, and they have both these points the same 0 coordinate, that is -2. Right? Right, and we look for intersection between these arrays. There is no intersection, so we do not know. So we do know. So we do know for sure that these two rows doesn't have any points with the same x coordinate, so we can't create a rectangle out of it. So we go to the next pair and next and next, and we check each and every one of them. And for example, let's look and say we went through all these pairs and we found nothing, no rectangles. Then we increase our offset, and now it is equal to 2. And now instead of going one step at a time, we take 2 steps. So we create pairs, let's say -2, and then we go 1, 2, we take this one, it's going to be -2 and 2. Then we have 0, and from 0 we create a pair 0 and 4. And we increase offset until it is as big as length -1. So our last pair in the very end is going to be -2 and 5. And doing that we cover all the cases, all the possible pairs of rows. And say we have somewhere a pair 5, 5 and 2, 5 and 2. And these are keys. What are the x coordinates? 1, 2 and 3. Let's put it here. 1, 2, 3. Now for 2, what are x coordinates? 2 and 3, right? 2 and 3. And what is an intersection between these two arrays? Well, it's 2 and 3. So we know that in both of these rows, in row 5 and in row 2, we have 2 and 3 axes. And this is our rectangle. But imagine if it wasn't just 2 and 3. What if there were a lot more dots on this line and on this line, the same dots that intersect? Like if it were 2, 3 and 5 and 10, and here as well 2, 3, 5 and 10. What do we do then? Well, we iterate through that and we try to find the smallest difference between two numbers. Like 3 minus 2 is gonna be equal to 1, 5 minus 3 is 2, and 10 minus 5 is 5. The smallest is this one. So we only work with this one because all the next one are going to be bigger, because this is a we can't create smaller rectangle from the others because y coordinate difference, it's fixed for us because it's the same for both these rows. For all of these points, the difference between y coordinates is the same, and area depends only on the difference between x coordinates, and this one is the smallest. I mean, it's definitely smaller than 2 and 5 or 2 and 10 and so on. So if we have a rectangle, we do not have to look into bigger differences between x coordinates, right? Right. So also for an offset, at some point we do not have to check every pair, because if we found a rectangle somewhere, like here we found a rectangle, what's it gonna be? Difference between 5 and 2 is 3, so one side of it is 3, and differences between 2 and 3 is 1. So its area is 3, right? Right. Now imagine that we increase offset, and offset is 4. Offset 4. But we understand immediately that whatever we have in this offset, let's say we have like 1, 2, 3, 4, 5, and from 1 we take 2, 3, 4, this pair. Let's think about the minimum rectangle we can find here. So the difference between y coordinates is already 4, and the minimum difference between x coordinates can be only 1. The minimum, it can be bigger, but the minimum is 1. So the minimum area that we can have here is 4, and our rectangle area is 3. So if our area is smaller than offset, then we don't even want to look at these pairs. You see? Now what failed me? What failed me? Look where I have my pairs array. And here I add elements to pairs. So on the very first offset 1, I add some pairs blah blah blah. I iterate through these pairs and I say found no rectangle. So I increase my offset and I want to add new pairs to my array of pairs, but I do not clean whatever I had there. So I still have this in my pairs and I add more pairs with new offset and I iterate through the same pairs again, and I do it on every increase of an offset because I create my array so early. And if I move creation of this array, say here, I'm gonna solve this problem. And not only I'm going to solve this problem, I'm going to solve this problem. I mean, it's gonna be green, huh? So you see, my logic was sound. It was a nice logic. It was just a small mistake that ruined me. And I'm so happy I was able to solve this problem, even though it took me, it took me 5 days, but I did it. And do you remember how we encountered this problem in the first place? Well, I tried lead rooms and there were 2 easy problems and 2 medium problems, and I was able to solve easy problems, and this was one of the medium problems, and I only solved this one right now, and you have another one to solve, and I think it's even worse. Let's look at this problem. So it takes me like a week to solve one room. Let me find this problem. Oh, it's ugly. Minimum score by changing 2 elements. Oh. Let's remove almost everything because it's bad. So we have 1, 4 and 3, and we can change 2 numbers to pretty much anything else. Is it anything else, or it just between 1 and 9? I'm not sure. Probably it can be something bigger. Yeah, it can be bigger, but it doesn't matter. The thing is, we can change 2 numbers, and the question is, we look for a minimum difference, and it's an absolute difference between 2 numbers, 2 consecutive numbers, and the maximum difference. And then we combine minimum difference and maximum difference, and we have this score value. So what is the minimum score value that we can achieve with 2 changes? Oi. And when there are just 3 elements, it's always gonna be 0, because we can just change, we can make all 3 elements equal, and then we get 0. But in all the other cases, it's a lot more different. And I've been thinking about this problem during my morning run, during the shower, the breakfast, and whatever. And I think maybe there is a pattern here. As the second change, we can always take, let's say, the first element and make it equal to the second element. We can always do that, and then we're gonna have the minimum differences equal to 0. So as a first change, we probably want to find the maximum difference and try to make it smaller as small as we can. Then on the second move, we want to check what would be the best thing to do to make minimum difference 0, or to make some action with maximum difference again, you know, because on the after the first step we may have something like 1, 2, 3 and say 8, right? We can change like to make 2 and 2, 3 and 8, but the biggest problem for us isn't that difference, it's that difference. So it would be much better to do 1, 2, 3 and I don't know, 3. Maybe something like this. But it's so hard. I remember we had a method in Ruby that creates pairs from like consecutive elements. What was it called? Let's check. Ruby method to create pairs from consecutive. How do that? What is the word? Each slice. Let's check. Let's call it pairs nums each slice to an array. And let's look at these pairs. No, it's not that method, obviously. Okay, let's do this the old way. Jesus. Something like maybe not. Okay, let's map with index, of course. Map with index. So we're gonna take -1 and nums, not minus, underscore 1 and nums underscore 2. +1, of course. Can we pop like this? Nope. Oh yeah, pass pop. And there is a method that does all that. Just don't remember which one. Yeah. So we have all these pairs now. Let's do pairs map sum. And we see that 15 is the biggest. Well, it's not sum. What we gonna do there? Okay, let's map. It's gonna be -2, and it's gonna be absolute. So let's say max equals to this, and then we want to find next index. I mean, in this situation, when we have three pairs that give us the same result, we want to change the first one. Probably we want to change this twice, exactly what they did here. I just do not know why they used 6 and not 7, for example. That I do not know. So let's say max index is gonna be no. Whoa. As usual. You know what? That LeetCoder, I was able to solve rectangle problem that bugged me for 5 days. 5 days. Now there is next problem from the same lit room. That's gonna take me another 5 days probably, but I'll get there eventually. So if you like suffering as I do, subscribe and follow. damn right, that's nice. See max array. I hate problems like this. There are so many edge cases. Oof. But it's doable. Yeah, we'll see you in 5 days. And I'm gonna have a huge beard, something like that. But I'm gonna solve this. For now I'm gonna do this the stupid way. Of course it can be done a lot easier. Not easier, in a more effective manner. Max array, yeah. Index of okay, let's look at this. Max index gonna be equal to 0, I hope. Oh, it's not index of. Is it index of? I don't remember. No. Oh, just index. No, find index. Yeah. Maybe in JavaScript it is called index of. Every day we learn something new here. Great, it's 0. And we need an if statement here. So if it's more than 0, it's gonna be one thing, but it's not. So we're gonna have first pair, and it's gonna be max array max index, and we're gonna have second pair, that is max index max array max index plus 1. So we have these two pairs. Now we have to figure out the most optimal change that we can introduce. Well, in this situation, when we do not have a block to the left, we want just let's make this change. Also, one. Wait, no. It's pairs. It's pairs. It's also pairs. Everywhere we're gonna use pairs. But it's an easy case, you see? And of course our second change gonna be I do not know why they have 6s in their example. I'm gonna have 7. What do we want to return in the end? Now we want to do that again. And of course there is an easier way, I understand that. I just want to solve at least this test case number 2. Of course, but what if Let's use this test case. Bah. Say I want to return max array. So where is our maximum here? Oof. That is our maximum. Now we're gonna have 3 pairs. Like previous pair is gonna be equal to pairs max index minus 1 it's called left pair pairs max index, and of course we're gonna have a right pair. And now we want to try understand let's return pairs for now. Let's return this. Oh. I'm tired. So we want to change this middle pair, but we want to understand what number do we want to change. I mean, we can turn 72 to 25, for example, but then we want to change this to 25 also, and we're gonna have a huge difference here. Or we can do 72 here, but then we need to add 72 here, and we're gonna have a huge difference again. They have to be consecutive, no? Oh, that's bad. I'm sure. Yeah, J can be anywhere just after I. Well, yeah, maybe it simplifies things. Okay, so let's think about it. There's nothing to draw. Oh no, where is this one? By the way, LeetCode, have you seen this wonder? I was able to solve minimum area rectangle just in 5 days. That was beautiful. How many days I'm gonna spend on this one? Thank you, thank you. Okay, let's look at our example here. So and it can be very long. So in this example, if we it's a miracle that I was able to solve some of the test cases. Well, the logic stays the same. We can always make our minimum difference, this one, equal to 0. The question is what we want to do with our maximum difference. So the maximum difference is going to be the difference between like a minimum number and a maximum number somewhere to the right, anywhere. And having that many elements, well, we do not want to actually check. We just need to take the biggest one. Well, there are two ways of doing so. Well. We can take the smallest one, increase it. No, not smallest. And then make its neighbor equal to this new smallest one. Something like this. So in this case, 25 is the smallest. '79 is the biggest. So if we turn 25 into 79 and 31 into 79, then minimum difference is going to be 0, and maximum difference, if we have 79 here, 79 minus 65, and it's 14. Okay, so we just need okay, let's do this the simple way. Now, for starters, what the hell is going on here, by the way? Oh, okay. No, not okay. We do not need any of this. But I think I have a plan. Okay, let's iterate through our nums. We want to have let me do a funny thing, like definitely we're gonna fail some test cases. I just want to test a funny thing. Let's sort and let's take last two. It's gonna be an array, right? Yeah. It's not gonna work here, by the way. Yeah, because it's not that simple. But it's gonna work here, I guess. Okay, let's find the minimum. It's nums min. We're gonna do this a simple way, no iterators, just for now. And probably we want to have a minimum index or not. Nums max. Yeah, we want to have indexes. So we have to iterate, but no, it's not that simple. Still, it's not that simple. It's like we want to create a hash like where is the maximum number located for each of our numbers. Where is the maximum number for one located? Well, it's gonna be like 8. Oh, but yeah, it's such a strange example, you know. By my logic, we're gonna take 1, change it to 0, then we change 4, not to 0, to 8, then we change 4 to 8, and we're gonna get the same result. Oh, that's stupid. Bad examples. What was it? I forgot. Find index. Of course we can do this by iterating, and it will be a lot more efficient, but for now I want to check, and I'm gonna turn nums min index into a nums max, not just max. Wait. This is our second change. We just can check it like this. We can't check negative indexes, not negative, yeah, negative indexes like this, because they would just start from the back again. That's gonna be our second change. Else, if we have both, we want to check which one is bigger. No, we want an if condition here. So if this is the case, this one is smaller, you want to change this one. Else we want to change that one. Or something like this, I guess. Let me how do we check the final result, by the way? Let's return our nums for now. It's still green, of course. Good. Here. Good. Yeah, still good. 14. Now we want to count everything. How do we count? Well, yeah. Obviously, we're gonna need a difference between nums I don't want to do this, but I'll do this for now. For now, last two elements. And it's gonna be 79. No. Well, of course, maximum and minimum. So we want nums max minus, not minus, oh, minus nums min, or not. Maybe not like minimum, but it's minimum to the right of maximum. So it's not gonna work for every case, I guess. We do not need absolute, but we're gonna solve some. Okay, let's hit some test case. That's exactly this situation. Let's use this test case and let's see. So this is the smallest, it's 9. We find 81, we put it here. Okay, but the difference is going to be between 27 and 81. No, we're gonna change this to 81 and we're gonna change this one to 81. Right now we have 27 minus 9. This is the smallest. 27 or not. Ah, it's hard. It's hard even because we have absolute values. Oh yeah, of course we need more thinking here. Ah. But 27 minus 81. No, it's not gonna be 81, 81. Then we do 59 minus 81, but it's absolute. This is a problem. What is the right answer here? $24. Oh, we definitely want to change this one, but not like the whole. Want to increase it just enough. No, no, no. Many changes. See. Yeah, it's not that easy. Too many edge cases. We need to understand the pattern here. That's definitely gonna take me more than a rectangle one. Take more time. Okay, let's have a break and solve something else. And for sure, I'm gonna have a sleepless night again. I'm gonna be thinking about this problem, whether I want it or not. And one day I will come up with a solution. Damn it, for sure we have a problem here that we have 9 and 81, and it's a huge difference. We definitely want to change this one, but maybe we do not want to touch 9, maybe we want to touch 81. Huh? Who said that we want to change the minimum number? Maybe we want to change the maximum one. That's why they have 6 here and not 8. That's because they understood something. What is 6? Why is 6? Where is 6? And we have 24. 24 is good. It's the difference between 9 and 33, by the way. So if we change 81 to 9, that's gonna be our first change. Then all of a sudden we have this huge difference and we change 59 to 27. We have 0 here, we have 0 here, we have 27 and 9 something here, but not too big. Yeah, we have a pattern here. How do we decide if we want to increase our smallest number or if we want to decrease our biggest number? Maybe we have to try both and compare the results. So this is like the one solution. It's gonna be our first result. And the second result is that so many ifs I need to solve this problem. It's gonna be like a huge list of conditions. Because this here worked only because 59 is the leftmost element. You know, we can do whatever we want with him. Okay, I'll continue tomorrow with this problem. Now I want to solve something desperately. Because it's time for me to go, to work, to eat, to have a date, believe it or not. Let's solve probably easy problem today, because yesterday we solved the medium one, and probably we are alone here, so no one would complain that it's too easy. What is it? Oh, I thought we solved everything on page number 5. If only. No such luck. Minimum cost to move chips to the same position. And we have position. We have n chips where the position of ith chip is position I. What? Let's have an example. So our position is an array and position of ith chip So zeroth chip is located in position number 1. Chip 1 located in position number 2, and chip 3 2 is located in position number 3, right? Yes. And our goal to move everything to the same position. Okay. What? 1? What is cost? Oh, cost 0. I see. So probably we want to move everything to position where we have the maximum number of chips already. So first of all, there was a nice way to do this. Tally ho. Let's check values. Great. For some reason, LeetCode can't draw hashes. I mean, we have a hash as a result here, but it just can't. You can only do tally, like hash keys or hash values. Is it the same for other languages, by the way, like in Python or in C++? Is there the same problem? Or it is just Ruby specific? So, position, tally, what is this, max by? I don't remember. Ruby hash key by max value. Yeah, max by. Like this. Max by underscore 2, right? Where is it? Nothing changed. Oh boy. Oh yeah, it's a pair, of course. Of course. Of course. Certainly it is. 2, 3, right. So this is our position. We want to move everything into position 2. And we want to iterate. Okay, it's not that hard. Probably there is a much easier way. So if position doesn't equal to our goal position, right? Yeah, here we want to check the difference absolute and if this is okay, let's put it into a variable. So if difference is odd, we're gonna do this, and we want of course to count everything. So what is it? 2. What? Oh, right, it's 1. That's it. Yeah. Now it's gonna be the same, or it's gonna be even, and then it can be jumped in 0 cost. This was ugly, and probably an easier way exists. Fucking shit. It's wrong. 6, expected 4. What's wrong with you? So here we try to move everything into position number 7. And we have 10 positions. Oh, well, if you want to understand it, let's draw 1, 2. It's an easy problem, so it must have an easy solution. 6. Can we? Yeah, we need more space. 7, 8. How can we move? We can't. Well, we probably can with the hand. With the red hand. Ooh. And where was our problem? Here. We have this chip in position number 6. Yeah, it's gonna take some time. We have this chip in position number 4. I already told you, my streams slowly turn into Sesame Street. We draw or we count. Sometimes I sing songs, so you know. And I have an accent like Count Dracula. Wonderful! Ha ha ha! Wow. 7. Or maybe I read everything wrong, as I do. No, it's alright. What? 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 Oh, crazy. What is this? Okay, let's not look there at all. So, 8, 2. Let's draw 2 at once. I can store 2 numbers in my operative memory. 10, 2. And 7, 9, 7. 7, 9, 7. Well, yes, you know. Let's count. We need 1 here, we need 1 here, we need 1 here, and we need here. I need to jump here, then here, and here. I can't even see. Boom, boom, yeah, it's a lot, it's a lot. So we do not want to go to position number 7. Wow, you know what? Sometimes it is possible that we want to move to some empty position. That's what's crazy. Yeah. Then how do we determine where we all want to go? I'd say it depends on, yeah, I know. We need to check how many elements we have in like even positions in relation to each other, and how many we have in odd, and depending on this we want to choose our position. Oh, that's funny. That's the funniest easy problem in existence. Oh, you know what? Let's brute force it. let's say we're gonna have two counts. Count even and count odd, you know. And what we're gonna do in the end, we want to check if our position is even, and if this is true, we increase our count even. Well, not entirely so. Haha. I'd say in most countries it takes like 18 years. Well, it's a lot for sure, because, well, we are closer to AI that can interact like a real person, but not, you know, to look like real person, or to like to have a skin like real person. So we are far from that. So far, it's like not anywhere near. So we're probably gonna have like philosophical discussions with our fridges and irons before we're gonna have a realistically looking and feeling Android. Let me just check this theory. It's definitely not a hard problem. And just we're gonna add position. We'll just now let's check what we have in both count even and count odd. Oh no, it's a dot. Don't want dot. Have 2 and 4. You know what, if we just plus 1 it, what are we gonna have then? 1 2, and here we're gonna have 3 2, and here we're gonna have 1 1. So minimum of this. Yeah, I'm moving the circle things with my mind. Let's see if I am successful. Yep. Cool. And we do not need this first line at all. And we can combine this into one line. Oh, great. At least we solved something today. And now I can continue with my day finally. I would suggest everyone to learn to code for fun. I think it's like a game, for me at least. It's like solving puzzles. It can be very entertaining and it develops your brain also at the same time. I would definitely code even if I wasn't dependent on it for money. Well, but you can find puzzles just for you, you know. You don't have to solve some very hard problems. You can solve the easy ones, just what's enough for you. It's like with everything, like with running or with weight training. You start with easy. I'd be good at MySQL probably. We'll check this tomorrow because I stream every day and I try to solve a problem every day, puzzle every day. So I'll see you tomorrow. Follow, subscribe, and so on and so forth. Whoa, thank you very much. Such a pleasant sound. Thank you very much. I appreciate it a lot. Now I have to go, unfortunately. I'll see you tomorrow. Thank you for being here in chat. Bye bye.